Okay, so the final section of Chapter 6, Lesson 6.5, we're going to go into multiple step equations and solving those. Now, you'll notice we had our one-step equations, and these were the steps that we used with one-step equations. When we go into two-step equations or multiple-step equations, we add some steps to it. Okay, you'll notice the first one is what I call unlocking the group. Okay, when we have in mathematics, we have an order of operations. When we're solving an equation, what we're actually doing is we're working backwards through the order of operations, because when we have an equation, we have a solution. We don't have the beginning. In a normal problem, we have the beginning and we work our way through to the end. When we're solving an equation, we're actually working backwards through that. So in these two examples here, you'll notice that we have grouping going on, okay? And so in order to solve any equation like this, and, well, let me work on the second one here. We obviously have a group here, okay? So 3x minus 2 is grouped. Well, because it's grouped, we can't touch it until we unlock it, okay? It is currently being grouped by this multiply by 2. So if I'm going to solve this equation, in order to undo this multiply by 2, or to ungroup this, I have to undo this multiply by 2 part. Okay, well, how do we undo multiply by 2? Well, we divide by 2, and whatever I do to one side, I do to the other. So in each of these cases, I'm going to go ahead and I'm going to divide both sides by 2. Okay, and you'll notice here when I do so, these end up being 1s, which means they're really not doing anything. And now this group is open wide, because all I have left here is 3x minus 2. And at this point, the group is unlocked. 12 divided by 2 is 6. I can go ahead then and go through solving the rest of the problem, okay? Because I have unlocked the group now. I can go ahead and start dealing with these. Now, since I'm going through steps, my next step is to isolate. When we were doing one-step equations, it was to isolate the variable. In multiple-step equations, is to isolate the variable term, which means we are going to go ahead and we're going to get the 3x by itself on the left-hand side. So I've got to now get rid of the minus 2. Well, how do you undo minus 2? Well, we add 2 to both sides of the equation. Now, one of the things I want you to get in the habit of is writing downwards. Okay, bring your solutions down, bring your steps down as you go along. Your organization will be much better in that case. Negative 2 plus 2, well, those cancel out. My 3x comes down to the next step. 6 plus 2, well, that's 8. Okay, so now I'm down to a one-step equation. Well, how do I undo multiplication? Well, I undo multiplication with division. Divide both sides by 3. 3 divided by 3, well, that's 1x. And 8 divided by 3 is 8/3, which you can express that in any number of ways. You could do that as an improper fraction, or it is an improper fraction. You could do it as a mixed number or whatever. Now, going back over here to the first example, you'll notice now the grouping here is being done by a fraction bar. Okay, fraction bars can be division symbols, or can be grouping symbols, and it is a division symbol. Okay, so in this particular case, before we do anything with the 3x minus 2, we have to unlock the group by getting rid of the divide by 2. Well, how do I undo divide by 2? Well, I multiply by 2. And this is a fraction, so I'm going to use the fraction version of 2, which is 2 over 1. Okay, yes, this is a fraction. It's just a complex fraction. Didn't mean to make that mark there. Okay, so we're going to multiply by a fraction, so you'll notice here I get to cross-simplify those fractions. And what's left? Well, 3x minus 2 is left. And if I'm going to multiply this side by 2, I better go over to the right and multiply by 2 as well. 12 times 2 is 24. Isolate the variable term on the left, so I've got to go ahead, again, I want to keep this, so I've got to get rid of minus 2. Well, the opposite of minus 2 is to add 2. those two. You'll notice the steps at this particular point are the same on both sides. Negative 2 plus 2, those cancel. Your solution's going to be a little bit different, but 24 plus 2 is 26. 3x comes down. How do I undo multiplication? I divide, so I'm going to divide both sides by 3. So x equals, and again, however you want to express this solution, you could change it to a mixed number, whatever. This particular case I'm not really worried about. Let's see, it would be 8, and that would be 24 and 2/3. So however you want to deal with that is up to you. So okay, let us go ahead and, if necessary, unlock the group. Well, no group. Don't have to worry about that. If necessary, isolate the variable term, which here is your variable term. Now notice the minus or the negative goes with the 3. Okay, so your variable term is this. So I've got to get the 15, and this is a positive 15. It's got to go. Well, how do I get rid of a positive 15? Well, I better subtract. So I'm going to begin by subtracting 15 from both sides of my equation. Again, there's your little balance for you, those of you who like your little balance scale. 15 and negative 15 cancel. Negative 3x, you're going to treat it as a negative. Negative 3x, I don't write 3's very well on this particular thing. So, but anyway, equals negative 6 and negative 15 is negative 21. Okay? Okay, now isolate the variable using multiplication or division. Because in this case I have negative 3 times x. Well, I undo multiply with divide. So I'm going to divide both sides by negative 3. Okay? Negative 3 divided by negative 3 is 1, so that leaves me with 1x. And negative 21 divided by negative 3 is negative 7. Sorry, positive 7. Negative divided by negative is positive. Now, and this is where checking it comes in to play. If I go back, because if I'd have put a negative in there, it wouldn't have worked out. 15 minus 3 times 7, does that equal negative 6? That's what we're checking for. I'll multiply before subtract. 3 times 7 is 21. My minus 3. 15 minus 21 is negative 6. Yep, it works. Negative 6 equals negative 6, and so that checks out. All right. Unlock the group if necessary. No group. Isolate the variable term. Well, my variable term in this case is the m divided by 5, so I'm going to leave it alone. I'm going to get rid of the plus 6. Well, how do I undo plus 6? I subtract 6, and whatever I do to one side, I do to the other. 6 minus 6 is 0, so my m plus 5 isolated and came down. Now minus 6 is 3. Okay, awesome. So this is my new equation, and I have division going on, m divided by 5. Well, how do I undo divide by 5? Well, the opposite of divide by 5 is multiply by 5. Now, because this is a fraction, I will multiply it by the fraction version of 5, which is 5 over 1. And whatever I do to one side, I'm going to do to the other. So the right-hand side here, you'll notice, is 15. Okay. And I do have a cross reduction here, cross simplification. So when I multiply, 1 times m is m. 1 times 1 is 1. M divided by 1 is m. So m, this is 1m equals 15. Let's check it. 15 over 5, I just replaced m with 15, plus 6. Is that equal to 9? That is the million-dollar question here. Divide or add? Well, divide. 15 divided by 5 is 3. So I've got 3 plus 6. Well, 3 plus 6 is 9. And 9 equals 9, so that checks out. Awesome. Works. All right. Unlock the group. I do have a group now. G minus 2 is being divided by 2. So how do I undo this divide by 2 so that I can then go to the G? Minus 2, well, I'm going to multiply both sides by 2. I'm going to use the fraction version because this is a complex fraction, but it's still a fraction. So now on the right-hand side, I don't have to use the fraction version because, well, it's not multiplied by a fraction. So let me go ahead, cross-simplify. G minus 2 times 1 divided by 1 is just G minus 2. So all of that over here simplifies down to G minus 2. Negative 46 times 2 is negative 92. So that is my new equation. And I will now solve this equation. Well, how do I undo minus 2? Well, I better add 2 to both sides. So I'm going to add 2 to both sides. My 2's cancel. So G comes down. Negative 92. This is a 2. Negative 92 plus 2 is negative 90. And if I check it, if I replace G with negative 90, negative 90 minus 2 divided by 2, is that equal to negative 46? That is the question. Well, negative 92 minus 2 is negative 92. Negative 92 divided by 2. 92 divided by 2 is 46. And a negative divided by a positive is negative. It checks. Here is a mistake, so I'm going to skip this one. You'll notice it is the same exact problem. So I'm going to go on, and that is an error on my part, but okay. Gets us to the end of our section. Again, I'm assuming that there are questions. Please come see me. It takes some practice. It takes some commitment here, and so when you run into those issues, please come see me. Anyway, go ahead. Good luck, and I will talk to you soon.